Okay, so we are going to cover on TCAP. So it is in the application layer of the SS7 that carries application to be exchanged between nodes. It is designed for non-circuit related messages. It is destined for database entities as well as actual and office switches. Its purpose is to facilitate multiple concurrent dialogues between the subsystem on the same machine. So the first use of TCAP was 800 number translations, where this 800 since 800 is not of a particular country code, it needs to be translated by a carrier. So TCAP helps a lot in that. Then other examples are intelligent networks, roaming in wireless networks, telecom services like automatic callback, line information database. So the addressing scheme used for the application using TCAP services is the subsystem number. The message unit at TCAP is the operation protocol data unit, the OPDU. So TCAP is capable of both invoking an operation and returning the results of that operation using the services of the SCCP protocol. TCAP offloads the applications from having to concern themselves with the mundane structures and dialogues. TCAP also provides a means of SCP to SCP communication via SCPs, for example, for queries and responses between SSPs and SCPs. SCCP provides the network services, whereas the MTP provides the physical layer and the data link layer functionality. So as you can see in the diagram, TCAP is in the SS7 protocol on the application part of the OSI layer. So let's take a look at TCAP references. So we have the transaction ID and the invoke ID. So the transaction ID is used as a reference within a dialogue so that the receiver can associate the received messages with the transaction in progress. So this transaction ID is significant to only the local receiver, but is sent to the remote as a reference to be used in any responses. We also have the invoke ID, which is used to identify invoke components, which are used to invoke the operation within the entity. One transaction may consist of several invokes, and the receiver of an invoke typically is expected to respond with a returned result, in which case a correlation ID is used to identify which invoke component the result is referencing. The correlation ID here is the mirror image of the invoke ID. Okay, so let's take a look at TCAP layers. So we have two layers. We have the transaction sublayer and the component sublayer. So the transaction sublayer provides the information necessary for signaling point to route the component's information to its destination. And this transaction layer has the transaction ID, which is used as a reference for tracking all TCAP messages. The component sublayer gets its information from the OPDU received from the application. The OPDU contains the primitives and the parameters necessary to invoke an operation or request services from another entity such as database query. Invoke components sent to start an operation are identified by the invoke ID. So that's the diagram of the TCAP layers, the component sublayer and the transaction sublayer. Okay, so now I'll invite Polycarp to continue from TCAP messages.
Thank you, Franklin. I'll begin with TCAP message details where Franklin has left. So for TCAP messages, we have the following types of messages, as you can see on my screen. But something to note on the messages, most TCAP messages are begin and end, as we shall see on the dump that were provided by Kamuch. So beginning with a unidirectional, a unidirectional message is used to handle unstructured dialogue, where two entities exchange mutually independent information for handling unstructured dialogues. Then you have the begin. The begin is used to start dialog messages. We have continue. Continue is used to continue structured dialogue, as the name suggests. And then we have end, that is used to end a structured dialogue. We have abort. The abort is used to abort structured dialogue. As the name suggests, that's the work of these specific message details on the TCAP protocol or the TCAP layer. There's something to note on the abort message type. When TCAP initialize the abort, that particular abort is marked as your abort. But when that abort is initialized by a user of TCAP, so maybe saying intelligent network or the map or SMS handler, it is marked as P abort. We are going to look at the message format of TCAP, and the messaging format of TCAP follows the ASN, the ASN notation format, or the abstract notation format. Sorry, abstract syntax notation format, and that is tag length and a value. The tag, as you can see, is made up of 4 classes. I hope you can get me clearly on these. 4 classes, what do I mean? So if a TCAP message tag starts with 00, that is a universal tag, as you can see. And if the tag starts with 101, it's application wide. And if it starts with 10, it is context specific. And finally, if it starts with 11, it's for private use, or it is reserved for certain information elements. If you can go back at the tag format, you can see the form is the second element in this specific tag format. So if the form is 1, like if that bit in the form position is 1, that means that this particular tag is a constructor element. But if the bit that is on this particular box of form is 0, that means this tag is a primitive information element. So a tag can be represented by any figure between 5 zeros or 4 zeros and 4 ones and 1 0. And for extension purposes, bit A, as you have seen, the first bit of the tag code, the first bit of the tag code is set to 0. And if we want to extend this particular tag, or if the information element is a constructor, the most significant bit, that is E, is set to 1. So instead of having 4 ones and 1 0, we have 5 ones, sorry. And then you have the length, and the length can be of 3 forms. We have short form, long form, and indefinite form. So there's something I need to clarify on this. For short form, that means it's a primitive information element. Like, it's made up of primitive information elements. That means it doesn't have a constructor, or if you can say, it's just a primitive information element. For an indefinite or for a long form, it has more than one information element. That is why we see here you have a most significant bit, and here you have a least significant bit. Same applies to the indefinite form. It has multiple, if not two or more, multiple information elements that follows the same syntax, that is tag, length, and value or content. I think we have discussed about this primitive and constructor. So it's just a quick overview of this. So for primitive, as I've said previously, we have a single information element, that is tag, length, and value. And for a constructor information element or a message, we have multiple information elements. That is, you can find one information element has multiple information elements, not maybe one or two, can be more. And it follows the same syntax, tag, length, value. That is why you'll find in the dump that we'll look at in the few minutes, we'll have several tags, then we have the content or the value of that specific information element. So the TCAP message structure, this is how it looks like. We have the transaction portion, we have the dialogue portion, and we have the component portion, as you can see. The diagram can explain very clearly that if you can look at the transaction portion, have the tag, length, and tag length, as we'll see in the dump that we have next. TCAP components, we have invoke, we have return result last, we have return result not last, and we have return, error, and reject. These two, return result last and return result not last, they actually work in almost a similar manner, but one is a negation of the other, if I can say that. The invoke component is used for requesting an operation. The return result last is used to send a final response to an invoke, which carries the final information of an operation. And the return result not last is used to send a not final response to an invoke. The return error component is used to detect an error. In case processing of information was unsuccessful, a return error component is sent mentioning the error and the cause of that particular error. And then you have the reject TCAP component. It's used to send invalid operation. That is in case an invalid operation was invoked, this particular component is sent. And let's look at a message dump that we can decode in the next maybe five minutes. So see, I have around 10 minutes. So we are going to take one dump at random and see what we got. So if I take this, can you see my screen, Malin?
Yes.
Okay, thanks. So if I copy a hex dump to the VS Code, so we have this message. I hope it's not so big that we can at least keep time. Okay, so now we start decoding this message. The first bit, as we have seen, it's tag, and the second one is the tag length. So this value here we shall see what this value is. Should be 4 bytes. This is the value here. Then we have tag length. Sorry, this is length, not tag. So here we count 7 bytes. This is a value here, and then we do a tag length again. Then we count 7 bytes up to this point. So these are value again. Then we do a tag length. Prefer separating them with space. Sorry, length. So just a quick one, if someone can help me to determine the length of this, that is 16 plus f. F is 15. That is 31. So we count 31 bytes. So is the value. So just a quick one. For the values, we have this one, the first one here, which is the transaction ID.
Sorry to interrupt. You have a typo in line 16.
Sorry?
Line 16, yeah. There.
Okay. Okay, so saying this here, the first one, the first value that we have on line 6 is the transaction ID. And then the second value that we have here, this is the ID as dialogue, or the OID, or if you can call it OID. And then we have this one. This here is the short message gateway context version 2. Maybe our seniors will help us understand the meaning of version 2, short message gateway. And then finally, we have the last value. Sorry, my time is up. And this is the actual value that goes to the map, as Brian will tell us more about it. And yeah, this is the, so if you have the dump that you're given, you can go and maybe confirm. I'm not able to share my entire window or my entire screen. I can confirm that the first value, the transaction ID, and so on. And I'm done presenting. Thank you guys for your time.
You're welcome.
Thank you, Polycarp. Walter, if you want to make a comment on the TCAP presentation.
Well, it's a good presentation. I'm glad we are going to add decoding the messages. Just one comment. Some of these, they're called what, tags, are optional, others are mandatory, but I think when we do the decoding, we need to make sure that we capture the cards. We capture and code for the tags that we really require for map to be specific for SMS service, because you'll find some tags might not be valid for our scenario for SMS, and we might find some unnecessary. And if we miss the ones that are necessary, we might have interworking issues with the remote end. So we just need to, at least it would be good to know which tags we really need for the service we are working on. Well, in the long run, we should implement for all, but that might take time. So as at the beginning, we just need to take note of which tags are really necessary for the proof of concept before, so that it can be expanded as time goes by. Back to you, Malin.
Thank you for that.
Malin,
Yes.
maybe I can also comment on something. One of the things that I saw, which is very important, I think this concept is not very popular within the IT world, where the OSI model has a functionality for transaction management. So I feel like it's a foreign, we don't have a direct comparison on the IT world for maybe TCAP, but for those of us who could think of how you manage transactions, this thing allows us to do, maybe you're sending many requests, but they're all linked, and that's why they have a transaction ID. When you're starting, you do begin. If you want to do the other one, you can do continue. And once you finish continue, you can go to the end. If you need to abort the transaction, then you abort. Sounds like a foreign concept. Yeah, sounds like a foreign concept, but it's something that we need to remember, that in telecommunication, maybe there are certain messages you exchange that are somehow related, and they could sort of messages that are linked to one transaction. So when you're starting, you do begin and end. The other thing is for SMS, I think most of the messages we've seen those SRIs for sending messages. They you use a begin and you get the results in an end. Then another thing that I also noted was that component bit, which I think is what carries now our message that we are supposed to send to the other server. So maybe that's just an observation for the guys who are moving from IT to telecommunication. But good job, guys who did TCAP, and I think that's okay. But if you guys have questions, Walter is here to help us answer questions. So you can chat them on, you can type them on chat, and then we can also have maybe some time to clarify what may not be clear for others.
Okay. I see one of the other mentors, Sam Anyona, is in the audience. Maybe you could say hi.
Hi guys.
Hello.
Sorry, I joined late. We had meetings up to quite late. But they're good presentations. I followed the last half of this.
We can go to the next presentation. Brian?
Hello.
Hello.
Hope I'm clear.
Yes.
Okay. Yeah, so I am Brian Kitunda. I'm representing Group 4. We are dealing with MAP. So MAP is mobile application part. It is a layer 7 protocol, the application layer. So MAP sits just above TCAP, which Polycap has taken us through. So that means that MAP uses the services of TCAP. So what are some of the facilities that MAP provides? The one in bold is what we are concerned about. It is the short message service. Other facilities that are provided include mobility services, operation and maintenance, call handling, supplementary services, something called PDP, packet data protocol, and location service management services. So those are the facilities that are provided by MAP. Now, to just bring things into perspective, we will review some of the GSM components that we covered in our first presentation. And we'll only review two, which is the HLR and the VLR. Now, the HLR is the home location register, contains subscriber information that doesn't change that much. And two key numbers that are attached to each mobile subscription that are stored in the HLR are one, the IMSI, which is the International Mobile Subscriber Identity, and secondly, the MSISDN. These are very key moving forward, and we'll see how in the coming slides. The next component that you're going to look at is the VLR. So the VLR is very close. I think it's closer to you, and it contains information about you that keeps on changing. So if you are roaming around, it means that you're being registered from VLR 1, 2, in that manner, because you're moving around, and that is what is going to serve you. So what are some of the key information details that are contained in the VLR? One is something we call the IMSI that we've discussed in the HLR, MSISDN, just the same from the HLR. And then something new, TMZ, which is the temporary mobile subscriber identity, just for security purposes. It is just a temporary IMSI. Then we have the location area where the MS has been registered. And finally, we have the supplementary service parameters. As we said, MAP uses the services of TCAP, which have been discussed by the previous group. And there's a lot of dialogue establishment between the two protocols. And so TCAP is very important for us to know. And thankfully, the team has just gone into details about it. So there's some common MAP services, and all of them are important for one of the following reasons. One is establishing and clearing MAP dialogues between MAP service users. So in this presentation, we'll hear so much about service users and service providers. So the U is for users, the P is for providers. I think even the TCAP team has discussed that. Secondly, accessing functions supported by layers below, TCAP, SCCP, M3UA, SCTP, all those. For reporting abnormal situations, there are services for that. For handling different MAP versions, still a service for that. And then for testing whether or not a persistent MAP dialog is still active at its side, there's a service for that. Now, some of the services that we are going to discuss include the MAP open. So the MAP open, as we discussed, we've talked about a dialogue. So the MAP open is used for establishing a dialogue between two MAP service users. And what are some of the primitives? We have an application context name, a destination address and the reference, an originating address and the reference. Then we have specific information. We have the responding address, we have the result, we have the refuse reason and the provider error. Then we have another service called the MAP close. So it is used for releasing a previously established MAP dialog. Two primitives in this, the release method, which can either take the normal release or a prearranged end, and finally, the specific information. These are the two primitives for MAP close. On to the next one, which is the MAP delimiter. This is used to request the transfer of the MAP PDU, the protocol data unit, to the peer entities. So it's a delimiter. It's like telling you that we're in the process, so just keep delimiting, just delimit. Yeah, so that is it for the MAP delimiter. Then we have the MAP UABOT. Remember, I told you that we have the service user, the service provider. The U is for user. So this is an abort that is triggered by the user. And some of the primitives include the user reason, the diagnostic information, and the specific information. On to the next one, the P is for service provider. So this is an abort triggered by the service provider. What are the primitives? Provider reason and the source. Next and the last service that we are going to discuss is the MAP notice. So this is used to notify the MAP service user about protocol problems related to the MAP dialog, not affecting the state of the protocol machines. We have only one primitive for this, and that is the problem diagnostic. Yeah, and that's it for the MAP services. We are going to look at some mapping of these services to the TCAP services. So the MAP open is mapped to the TCAP begin, or you can just call it TC begin. The MAP delimiter is equivalent or mapped to the TCAP continue on the TCAP. And then we have the MAP close, which is mapped to TCAP end. And finally, not finally, just these are just examples. The MAP UABOT is mapped to the TCAP UABOT. User abort, so you can be sure that you have the provider abort also. And it is the same for TCAP. So what are some of the common parameters used in MAP services? We have the invoke ID. I think even TCAP, we've seen invoke ID. So this has to be there. It's like the identifier for a service. Then we have a linked ID. The provider error. This indicates a protocol related type of error. Then you have the user errors. So these are grouped for readability. We have generic, identification or numbering, subscription, handover problem, and then finally operation and maintenance problem. Now we're going to discuss some other parameters that are involved in MAP services, and these are specifically numbering and identification parameters. When we started, we talked about the IMSI. So each SIM card has a unique identifier, and that is the IMSI. So if you do a SIM swap, you maintain your phone, you maintain your MSSDN, but the IMSI changes. Then we have the TIMSI, which I explained, just a temporary IMSI. Then we have the International Mobile Equipment Identity. This is identity for your phone, we call them the mobile equipment or the mobile station. Then we have the previous location area ID. This refers to the identity of the location area from which the subscribers roamed, where you were before. And then you have the stored, that is where you are assumed to be located. Then you have the current, where you are currently. Then you have other identifiers such as the target location area ID, target cell ID, originating entity number, MSC number, target MSC number. For the sake of time, we will not look so much into that. We have the HLR number, VLR number, HLR ID, LIMSI, and MSISDN. Now we come to the most important part of this presentation. This will be key. Now we are looking at building an SMSC. So our focus should be more on the short message parameters, and some of them, and you'll see them in the dumps that we'll be analyzing. The first one that we're going to look at is the SMRP DA. So the SM is for short message, the DA is for destination address. So this is where the message is being transported to. So the destination address can either be an IMSI, a LIMSI, an MSSDN, a roaming number, or a service center address. The originating address, on the other end, that is the OA, it can either be an MSSDN or a service center address. Then we have something called MWD status. The MWD means message waiting data. So there's a file where, let's say you try to send a message to person B, and person B is not available for some reason. And the two main reasons that you're going to be looking at is, one, the main reason why a message may not be delivered is, one, they were not reachable, the mobile subscriber was not reachable. Two, memory capacity was exceeded. So if you've used the Kabambe phones, at times messages won't get to you simply because your memory is full. So what you need to do is to clear the messages so that you can be able to receive other messages. So that is one source of you not getting a message, and the other one is definitely you not being reachable. So if you are not reachable, then a record is kept for the message that was not able to be delivered in the MWD file. So this is what this flag is for. This parameter is for that sake. Then we have the SMRP UI. UI means user information. This is what actually carries the actual message. This is the carrier for the actual message. Then we have what we call the PRI. So this indicates whether, if you are found to be in the MWD, whether you should attempt to send the message to you. So that can either be a 0 or a 1. A 1 means send, a 0 means do not. Yeah, so that's what PRI stands for. Then we have the SM delivery outcome. So the outcome of an attempted sending could be that it fails because of an absent subscriber or a memory capacity exceeded problem, or the message could get to you, so a successful transfer. So these are the three possible values for the SM delivery outcome. The other parameter is more messages to send. It indicates whether or not the service center has more messages to send. Yeah, that's yet another parameter. And then we have another one called the alert reason. So this indicates the reason why the service center is alerted. So if the message is not able to get to you, so it was in the MWD, and suddenly you are available, or now at least you have memory, you deleted some messages, then that has to be the alert reason. So it needs to be sent. It needs to be sent using this parameter. Another parameter is the absent subscriber diagnostic SM, indicates the reason why the subscriber is absent. Yeah. Then we have the alert reason indicator. This one indicates the alert reason is sent to the HLR due to GPRS activity. And also we have the additional SM delivery outcome. It indicates the GPRS delivery outcome in case a combination between a delivery outcome for GPRS and non-GPRS are sent to the HLR. So the rest are mostly indicators. So for the sake of time, we'll just move to the SR SM, RP, MTI. So this is the message type indicator, and I will request you to just tell me the two types of messages in the chat, so that we save on time. So you can just chat it there, two types of messages, and then we move. So now we are going to look at the real services now. I'm sure you've seen the SRI somewhere. So we're going to look at all of this. So we have the SRI, we have the MO forward short message, we have the SM delivery status, we have ready for SM, then we have the alert service center, we have the inform service center, then we have send info for MT, and we have send info for MO, and then we have MT forward short message. So we're going to look at each of them. We also look at the parameters that are sent, which ones make part of the request, which ones make part of the response, which ones are mandatory, which ones are optional, which ones are conditional. So let's go. So the first one, and for beginning, the green labeled parameters represent these that are part of the request. The invoke ID is in all of them, both the request and the response. The red labeled ones, those are part of the response. So an SRI, the send routing info for SM. So this is used between the gateway MSC and the HLR to retrieve the routing information needed for routing the short messages to the servicing MSC. So part of the request would include the invoke ID, the MSISDN, the SMRP PRI, which we said is a flag for whether to just push whatever is in the, if someone is in the MWD, do you still forward the message to them? Yeah, so that's part of it. Then you have the service center address. Then you have the MTI, which is the message type indicator. Then you have SMEA, and then you have the GPRS support indicator. Now, what comes back as a response? One is the IMSI. Two is the network node number. So in this case, it could be if you are dealing with the MSC, then that is the MSC number. Then another one is the LIMSI, and then you have the GPRS node indicator. We have an additional number. You have a user error, provider error. Remember the U and the P that we discussed when we were starting the presentation. Now, once the SRI is sent, you get a response, which we've discussed, IMSI, the network node number, and all that. Now, the next thing would be to forward the SM. Now, to forward the SM, these are the primitives that, so that means that you're sending it from, it's being served from the serving MSC to the SMS interworking MSC. So we are actually forwarding the MO. So the primitives would be: one, the invoke ID; two, the DA, which is the destination address, which could be MSSDN, a roaming number, a service center address. Remember the ones that we discussed, and it could be an IMSI. And in this case, mostly it's an IMSI. Then we have the originating address. Those are service center number, and yes, that is the originating address. Then we have the UI, which is the user information. We said this carries the actual message. Then we have the IMSI. Yes. And then you have so the ones that are labeled M are mandatory fields, as you can see, mandatory for SRI. Then the C is conditional. Yes. Then we have the response, which could be a user error or a provider error. Now, once a message is sent and it's delivered, you get what is called a delivery status. So let's look at report SM delivery status. So what are the primitives? The invoke ID, the MSSDN, the service center address, the delivery outcome, the absent subscriber. We discussed all these primitives. The diagnostic SM, the GPRS support indicator, the delivery outcome indicator, the additional SM delivery outcome, and finally, for the response, for the request, additional absent subscriber diagnostic SM. So part of the response include MSSDN alert, the user error, and the provider error. Moving forward, now the message did not get to you. So what happens is when you're back, for whatever reason, it could be memory or it could be that you are not just available. When you're back, you make radio contact to the VLR, and that would usually trigger a map ready for SM. And the primitives here include the invoke ID, the IMSI, the TMZ, the alert reason, the reason why you think you're ready, and the alert reason indicator. Part of the mandatory fields is just the invoke ID and the alert reason. The IMSI, TMZ, and alert reason indicator are conditional. So part of the response, user error and the provider error is always. So now, in this ready for SM, the MSC is what is alerting the HLR. Now, for alert service center, it is used between HLR and the interworking MSC. So HLR initiates this service if it detects the subscriber's MSSDN is in the MWD is active, or they have the memory available. So part of the primitives, invoke ID, MSSDN alert, and the service center address. So mandatory fields here are the invoke ID and the MSSDN alert and the service center address. Part of the response is always the user error and the provider error. And those are always optional. They are not mandatory fields for the response. Now, another one is the inform service center. It is used between the HLR and the gateway MSC to inform the service center which MSSDN is in the MWD file. In this case, the primitives include mandatory one, invoke ID, conditionals, MSSDN alert, and the MWD status. Now, once the message gets to the destination MSC, the MSC on the other end needs to send a request to VLR, and this request is to try and get subscriber related information from the VLR. So the primitives here include, this is for the purposes of the full delivery. Remember, when we did the SRI, what you get is the MSC to which to forward the message to. Now, on the other end, the MSC needs to find you. So that is why we're talking about the MT leg. So it's the send info for MT. So in this case, the primitives are the invoke ID, which is mandatory, and the destination address, which is mandatory. Part of the response is MSSDN. You know why you need it. And then the other fields in user error and provider error also part of the response. And then we have the send info for a more SMS service. This is just the same as the one that we discussed before. Just replace the T with the O. And as you can see, the primitives are the same. Are not the same actually, because here, this is the service center address. For the other one, that was the destination address. This is because it is the MO leg anyway. So that is why we're dealing with the service center address. The response fields are similar to the MT, to the send info for MT. Now, the last one, I think, yes, the MT forward short message. Now, once you've sent this send info for MT, now it's time to do the actual forward to the end user. So the service that is responsible for that is the map MT forward short message. So it is used between the gateway MSC and servicing to forward MT messages, SM. So the primitives include the invoke ID, which is mandatory, the destination address, mandatory, the originating address, mandatory, and then the UI, which is said is the user information, which is mandatory because that is what is carrying the actual message. And then there are more messages to send parameter that is used to alert that it tells whether the service center has more messages to send. And then you have the response fields in user error and the provider error. So these are the services, and we'll see more. We'll see them better in the when we start analyzing the dumps. So just to take you a little back, we look at how dialogue establishment happens. So this is a map primitive, map service. So map open will always have a TC begin on the other end, and then you do a map open response. So now you have a dialogue. Now it's time to just delimit. So TC continue triggered on this end, delimiting, and then once you think you're done, you have a TC TC end or a TC user abort. This should be a P, TCP abort, and then the dialogue is terminated. So now we look at some dumps here. So we'll just look at it on a high level. So this is the first one. This is an SRI, and as you know, we need to send an MSSDN. This is the MSSDN. So this 9.1, first nibble, second nibble, they set some flags here. You see the extension. So this is the standard, and then from the third nibble to the last nibble, that is what forms part. This is just a normal MSSDN played around with. As you can read this as 2, 5, 4, then 7, 2, 2, 8, 4, 8, 0, 6, 2. That is the real MSSDN. And then remember, this is an SRI. So we said some mandatory fields. We have a PRI, which was supposed to tell whether if the number is found in the MWD, whether we need to do the forward. And then you can see the service center address here. And then that is it. So the response that comes back to us is this. And there are two key things that you need to see from here. We requested, we sent an SRI, and we are looking for the routing information. So one thing that needs to get back to us is the MSC number, because that is where we're routing. That is where we're doing our routing to. So as you can see, we have the routing number. We have the MSC number here. It's here. It looks like a MSSDN, but it's not. It's the identifier for the MSC. And another key thing that we have back is the INSI. Here it is. The INSI starts with the MCC, which is the mobile country code 639. Then the 02 is the MCC, is the MNC, the mobile network code. Then after that, we have a forward SM, and you'll see all the primitives that we discussed. We have the invoke ID, we have the opcode, which is 46 for forward SM. Then we have the destination address here, which is an INSI that we got from the response of the SRI. Then we have the OA, which is the originating address, which is this. It is a service center address for this case. And then we have the UI. This is the user information. This is the actual message now. This one. Sorry. Let me try and trace it back. Yeah, this one. This is the whole message now. Yes, and that's it. I hope you've gotten to see some of the primitives. Yes. Now the next part is the part where we just did something extra. We did the actual decode. We did something here, and we played around with what we learned, and we can just run this and see what we have. So the total size of the map message is 29 bytes. That is for the first one. This should be 31 bytes actually. It's 29 because by the time we get to this point, we've already done we've done tag length. So it means now at the point where we're talking about the actual map message. So it's 29. Then you have the invoke ID, which is 1. The operation code, the first one, the SRI, the operation code for SRI is 45. 46 is the other one, which was to submit SM. And then we have the MSSDN here. And then you have the PRI, which is 1, meaning that if you find the number in the MWD, just deliver. Then you have the last part, which is the service center address, which is this. Yeah, so that's it for our presentation. Thank you. Over to you, Mali.
Thank you, Brian. Thank you for that. Walter, do you have anything to comment or Kamocho?
Nice presentation. I think the presenter, you did well to give various identifiers that we require and the various operation codes. I think the presentation generally was good. It covered most of the parts. And to end it up, you also managed to do a small decoder, which is nice. I think keep the hard work. I know it is hard, but keep it up. If we continue with this trend, we will be able to hit the target. Nothing much from me, Marlene. Back to you.
Okay. Sam?
Yeah, my sentiments are the same as Walter's. It's good that you've gone through the various messages that can be sent and what they're for. It's good to understand from that point of view that this message is for this, then this message is for this. Because now we're going through the stack, and at the level we are now, you're looking at transactions and what are the machines actually talking about, or what are the requests about. So it's good.
Okay. Kamuchu? Anything to add into that?
Yeah, Marlin, that was a good presentation. I agree with what Sam and Walter have said. It was a good presentation. Maybe the only thing to help our people understand, one of the key things I have taken out is MAP talks about MAP dialogues, and there is those MAP opened, and I think we've seen how they are related to the primitives on the TCAP layer, or the TC. Some people, I see some protocols calling the TC transaction capabilities. So we can see how they are related. The only thing I would like to say is that, yes, we normally talk about HLR, SMSC, VLR, and the messages that are being exchanged as part of the processing. So the key thing we need to remember is that, yes, there is maybe the integration between SMSC and the HLR to find where the guy is, the person we need to deliver the SMS to, is that SRI, or send routine information. My highlights, and I've seen a lot of operation codes that have not interacted with. So very good job, guys. I've at least I've seen the ones that interface to the SMSC, but seeing the operation codes that even interface between the switch and the VLR, it was quite exciting from my perspective, and seeing the parameters that are part of that request. So those parameters, whether it's IMSI, TIMSI, whether it's the MSISDN, if you are from an IT world, just think of them as the parameters you make in your API request, whether you are using JSON, only that here we are encoding using binary. The protocol is binary, so we are encoding the bytes using various ways. And you've seen TLV, or the tag length value encoding, being used in many of those layers. Luckily, we had covered that, I think, in the last hackathon. Guys were able to deal with TLV encoding and all that. It was a new thing we never taught you, but later you guys came to appreciate what TLV does. So for me, is just for those guys, and I saw someone suggest, we just need to remember that, yes, we said SCCP is at the lowest layer, and the work of SCCP is to ensure that we send messages via socket. There we learned about associations. We should not forget about it. Then we brought M3UA, which brought some interesting aspects of networking. So we talked about the point codes and how point codes were used to route, or to route messages from one node to the other. We learned about the limitations of those point codes, and we went to SCCP that tried to bridge the gap of the limitations that we had in the lower layer, which was M3UA.
And there we learned about the GTs, or the global titles, which I think we were given a very good analogy of a global title is a unique ID for a network element globally. So the SMS in Safaricom has a global title that is unique globally, but the point code, and Walter took us through the different, I don't know whether there were classes, but it's very difficult for you to have unique point codes. There are 14 bits if you use the ITUT standards, which is basically gives us less addresses than even IPv4, which we know is not sufficient for networking within the IP, because we have 4 billion IP addresses. 14 bits, we have, I think, about 16,000 or so addresses, which are way lower than we can have in terms of internet working of all the telecommunication networks. So we saw how SCCP can help us in managing things like connection-oriented and connection-less communication, similar to TCP and UDP. We saw that very well. So SCCP has some functions that appear to be on the transport layer in our OSI modem. And it also has some functions that appear to be on the network layer based on the OSI modem. Then, of course, we saw TCAP today and how TCAP helps us to achieve transactions. Maybe what I would pose to Walter and Samanyona is maybe scenarios that allow us to do begin, continue, then end. I don't know. On SMS, all the traces we have, they have a begin and an end. So maybe you could share scenarios within the telecommunication network that do that we can see, we expect to see on the network a transaction begin, then we have a continue, and a continue, then end. But when we looked at the map survey, yeah,
I think when you're looking at update locations, then
even
you
a
have
multi-part SMS.
ISDs.
Or even a multi-part SMS.
Or
even a
multi-part
Oh.
SMS or the update location. Then you have then you have ISDs, several ISDs, inside subscriber data. You acknowledge, then continue.
Okay. So even USSD, we expect to see, as we are responding with Del star 44 hash, the first request is a TC open, yeah?
Yeah.
And then when the guys keep exchanging, we do that continue until the end. When you close the session,
I'll get some traces, then share.
Thank you. That would really benefit us, because we need to see those scenarios so that we stop being theoretical. I don't know, maybe does interaction with the IN? I know there is CAP.
For the IN, similarly on CAP, you'll have those ones continue, like an IDP.
Okay, and the other detection points. So maybe for those guys who might be lost with what I'm asking, when you initiate a phone call to your friend, so the switch talks to the billing system, which we call the IN, and uses CAP, which rides on map, which is basically it rides on TCAP, yeah. It rides on TCAP. So it has a TC begin and then continue as maybe 30 seconds, the switch keeps talking to the end to ensure that we take away the balance and we give you more quota. So it's a reservation concept, and maybe we can see. So if you could show us some of the dumps, I think they could help guys. Although we are not working on those things, they could help us figure that out.
Okay, I'll take some traces and I'll share with you.
Yeah.
Just a comment on that. Normally, wherever that type of transaction requires several messages, then we will have several continues in between.
Oh, okay.
Yeah.
Yes.
Yeah. And I remember, I think, Walter, you mentioned about multi-part SMSs. For those who are not there when guys were discussing the call flows, I think we realized, I think it was Francis Kinyoru,
who told us that he actually mentioned it last week when he was doing actually on Tuesday when he was doing the the call flows for the SMS in his presentation. But we saw that we call it a short message because if you use a character to be represented as 7 bits, we have 160 characters. But if you use 8-bit, you have 140 characters. But if you have 16-bit like Unicode, you have to get 70 characters. And one of the things you find is that a customer might decide to send a 300 characters SMS to the other guy. So what happens is when we are communicating, the system has to break the message into smaller parts and send them through. So you do a begin and then you send the other small parts in the same session. Once you finish, in the same transaction, once you finish, you end. I hope that's accurate, Sam and Walter.
Yes.
Yes, that's correct.
So from where I sit, I think we can see TCAP has the functionality of helping us do transactions. And it is very common within the telco where even when you're browsing on your data session, I know we might not be using SS7 there, but 2 MBs are reserved every time. So it's like you have a transaction that is continuing, or you could think of it as maybe a session, too many requests being sent, but they're all related to one transaction ID. So for voice calls, that works very well. For SMS, they are normally, we call them events. So you just send an SMS and you forget. But for a voice call, if you talk to a guy for 20 minutes, a lot of TC continue messages are exchanged as the call is ongoing. So that you could come and probably think of the TCs being able to help us have too many exchanges until the session or the transaction is complete. So I think that is that on that side. On the map, I think the key thing, we focused on the map for SMS, but I think I also picked a very good overview by Brian, where he talked about map is used even for any other services. But when he was giving us the operation codes, he focused on the operation codes that affect SMS, whether it's between SMS, C, and the HLR. Again, as we said, always think those messages as APIs, just like the ones you create on JSON, only that they are not HTTP. So we just need to get that mentality. And those primitives, as Brian was calling them, they're just parameters in your request. Just like the way you could send a request to the core banking system to withdraw or to transfer, you have to say the source account, the destination account, and the amount, and the currency, and maybe narration and other things. So if you're designing the system, you could have so many parameters. So these APIs were defined by the different bodies that define the service. And this body is actually the GSM that was able to come up with the APIs to be used for SMS service communication. So that is, I hope we have helped someone. I don't know whether there is anyone who feels like they have benefited from that. But these things are not just abstract things. You need to know what they mean. So Marlin, thank you for giving me a chance. With those many remarks, I want to hand over to you. For the team, if anyone has a question, Walter, Anyona, ourselves, we are here to help ourselves, to help you learn and to help ourselves navigate through these concepts that may appear complex, but in real sense, they're not that complex.
Thank you for that, Kamachu, and to our mentors, Walter and Sam. Thank you for your insights today. That will bring us to the end of the research analysis part for the project. The next time we'll be speaking, Kamachu will be taking us through what we expect for the development phase of this project. So